Swayam Prabha. Digital India. Educated India.
We are going to start next with experiments and go into the details of understanding the various concepts that are linked to the understanding of causal estimates. Particularly, we are going to focus first on the average treatment effects. That is, if you assign individuals or firms, basically your observation, your units of observation, if you assign them to treatment, then if you had 100 such units, let us say, then what is the average effect of the treatment across the 100 units. So, to understand this concept, let us again go back to the example that we had taken previously in terms of the question, do hospitals make people healthier? So, as I had shown you before, a naive comparison of health status of those who went to the hospital in the last 12 months at least once, and those who did not go to the hospital even once in the last 12 months, a naive comparison between them might lead you to believe that hospitalization actually leads to worse health outcomes, as we see that the mean is higher in the case of hospitalization as compared to non-hospitalization. And remember what I told you before, that in this particular survey, that from where we summarize the data over here, it was asked to the individuals to rank their health status on a particular day on a scale of 1 to 5, where 1 represented the best health status and 5 represented worst health status. So, which means that a 2.79, a higher mean value, reflects a worse health outcome. So, no hospitalization has a better health outcome, and people who went to the hospital at least once in the last 12 months had a worse health outcome. Now, do we interpret this result as saying that hospitalization actually leads to worse health outcomes, or do we consider the possibility that there would be confounding effects when we look at individuals in a survey data who did go to the hospital and compare them with individuals in the same survey data who did not go to the hospital, where hospitalization was obviously a choice that the individual made. Similarly, so this is an example that I showed you from the typical health concern, but suppose we are talking about another aspect, which is the labor economics or the human resources personal economics concern. So, typically there are many programs worldwide which are targeted towards individuals who need a job. So, particularly to disadvantaged workers, long term unemployed people, maybe they are ex criminals, drug addicts, etc. So, in many countries, for instance in Europe and US, what you find is there are job training programs, so that these people can learn the skills that they need to get re-employed. So, the question here is, do these job training programs lead to better employment and earnings opportunities for these people? Now, typically what you would do is, you would have a survey data where you ask individuals whether they have had taken or participated in the job training programs, and then you also have in that particular survey data you would have individuals who have not participated in these job training programs. And typically what you would do is, in a standard linear regression model, you would be looking at the difference in the earnings or employment probability of individuals who participated in the job training program to individuals who did not participate in the job training program. So, when you compare, the comparison of participants and non-participants often show that after training the trainees earn less than the comparison groups. What does it mean? It means that people, the average employment outcome of people who participated in the job training programs to the average employment outcome of people who did not participate in the job training programs. When you do this comparison, you find that people who participated in the job training programs are actually worse off than people who did not participate. Does this mean that the job training programs are absolutely useless? They do not benefit. On the other hand, they actually harm these individuals because they worsen their employment outcomes, they worsen their earnings outcomes. But the question is whether this is the right but the question is whether this is the right question to ask. For instance, what do you think? Do you think that this result that you saw on the previous slide, the fact that individuals who participated in the job training program have worse outcomes in terms of employment and earnings, is this a reflection of an ineffective program, or is there a selection bias? So, what do we mean by selection bias? Selection bias essentially means that the kind of people who volunteered themselves into the job training program that you observe in the survey data are different, are selectively different from people who do not participate in the job training program. So, what would your answer be? Think for a moment and then I will go on to the discussion. So, it turns out that it could be either of these answers. So, for instance, it could be an ineffective program, we do not know. It could also be selection bias which is leading to this problem. So, what is going on over here? It is possible that people who participated in the job training program are disadvantaged to begin with. So, their outcomes even before they actually participated in that program is much worse than the people who did not participate in the program, because the people who did not participate in the program voluntarily are essentially people who do not need the program, are relatively advantageous compared to this other group. So, what you are comparing is not an orange to an orange, you are essentially comparing one orange to a completely different fruit, maybe apples over here. So, it could be any other fruit that you can think of. So, essentially these are two different groups. So, we do not know whether there was a selection to begin with. Indeed, when people ran randomized experiments, what they found is they found positive training effects. So, when they randomly picked individuals and put them in the job training program, and for some other people they did not put them in the job training program, they found that the job training program was beneficial in terms of improving the outcomes, the employment and the earnings outcomes of the treatment group. So, let us now formalize the whole idea of the average treatment. So, in order to understand the average treatment effect or to define average treatment effect, suppose we wish to measure the impact of a treatment on an outcome y. Let us say the treatment is denoted by D. So, for the moment we abstract from other covariates that may impact on y. We only consider D as the variable that we are interested in that would affect y. So, we are interested in the causal relationship from D to y. So, denote by D the treatment indicator, a dummy variable assuming the value of 1 if an individual or the unit of observation, to be more general, has been treated, and it takes a value 0 if that individual or the unit of observation has not been treated, which is if they are in the control group. So, the outcome of interest in this case is denoted by yi, and the question of interest is yi caused by di? So, to understand this, we define two further terms, which is the idea of this potential outcome, what we had defined before as the counterfactual. So, suppose you put individual I in the treatment group, that is the individual gets the treatment, then we define the potential outcome as y1 I if the individual belongs to D I equal to 1, which is if the individuals if an individual I belongs to the treatment group D I equal to 1, then the potential outcome for that individual is represented by y1 I. And if the individual belongs to the control group, that is D I equal to 0, no treatment, then the outcome, the potential outcome for that same individual is represented by y naught I, y 0 I, right. So, this is essentially the counterfactual outcome for that individual, and the measure of interest is what is the difference between the outcome of this individual had that individual been treated, that is di equal to 1, and had that individual not been treated, which is di equal to 0. So, the measure of interest is obviously y 1 I minus y naught I. Now, when we say potential outcome, remember we are again going back in time and saying that we will put that same individual in the treatment group once, observe the outcome y 1 I, go back in time, put the individual in the control group next, which is y naught di equal to 0, and observe his outcome y naught I. So, these are essentially parallel worlds, in other words. So, this is a theoretical concept, it does not mean that you actually observe both y 1 I and y naught I for the same individual. But anyway, so theoretically the concept is the observed outcome y I can then be written in terms of the potential outcomes as y I, which is the observed outcome, is equal to what is your status before the treatment, which is y naught I, and then what do you gain from the treatment, which is the measure of interest that we saw earlier, y 1 I minus y naught I, and notice that if di equal to 1, which is if you get treated, then this term gets added to your initial condition, which is y naught I, and what you get overall is what is your y I or the observed outcome after you get treated. But at the same time, note that if di is equal to 0, then what you have is just y naught I, because this treatment, this individual was not treated, he does not gain anything from treatment, and hence he remains at y naught I, which was his initial outcome before the treatment. Now, when we talk about average treatment effect, we are saying that every individual has the benefits, either benefits or has a treatment effect essentially. So, we would observe an effect of the treatment or not. Now, if we observe an effect of the treatment for every individual, it is not necessarily the case that every individual would get affected by the same treatment in the same way. So, every individual might have a different effect of the treatment. So, when we go to the population, we would have an entire distribution of y naught I and y 1 I. And what we are interested in is the average effect of the treatment across all these individuals. In reality, every individual might have a heterogeneous effect, in the sense that every individual might benefit differently from the same treatment. So, the y 1 I minus y naught I that you observe for every individual might be different across different i's, in other words. So, once again, just to go back to the concept, this is a theoretical idea of what is the average treatment effect, and to build on the average treatment effect, what we define here is potential outcomes, which are counterfactuals y 1 I and y naught I. So, what is the outcome had the individual been treated, and what is the outcome had the individual not been. So, in reality what happens is what we observe is a naive comparison of averages by the treatment status, what we saw in the hospitalization example before, or even the labor market example before. So, what you do is, or what you observe is, the y I, which is the observed outcome for the individual had that individual been in the treatment group, and what is the y I, the observed outcome for that individual, for other individuals actually in this case, for people who were in the control group. So, to draw an analogy with the hospitalization example, here the expected value y I given di equal to 1 is essentially the outcome, the health outcome of people who were hospitalized. And this term over here, the expectation of y I given di equal to 0 is the expected health outcome of people who did not go to the hospital. So, your di equal to 1 in this case, in the hospitalization example, are people who were hospitalized at least once in the last 12 months, and di equal to 0 are people who were not hospitalized even once in the last 12 months. And this difference is what you saw in that table on the very first slide. Just to go back to that slide, what you saw was this mean over here 2.79 and the mean 2.07. So, these are the two numbers, and the difference between these two numbers, which is 0.72, is what you would get when you take the observed difference between the two groups that we have over here. Okay. So, in other words, what we write down is this observed outcome in terms of the potential outcomes. The observed outcomes in terms of the potential outcomes are basically the expectation of y1i, which is the potential outcome for people who were hospitalized, because that is what you observe. For people who were hospitalized, you only observe the potential outcome for them if they were hospitalized. You do not observe the potential outcome for them if they were not hospitalized, but at the same time, for people who were not hospitalized in the last 12 months even once, for them you only observe the potential outcome had they not been hospitalized. So, the observed outcome for this group is the potential outcome had they not been hospitalized, and this is how we just modify the first on the left hand side of this equation to write it down in terms of the potential outcomes. So, in other words, what you do not observe is, you do not observe y1i given di equal to 0. You do, and you also do not observe y naught I given di equal to 1, which is you do not observe the potential outcome for the group that was treated, that went to the hospital, if they were not treated. You do not observe the potential outcome for the group that was not treated had they been treated. So, we can further rewrite this just by a little manipulation. We add a term which is the potential outcome for people who were treated, their potential outcome had they not been treated. So, which is y naught I given di equal to 1, and we first subtract that particular term and then we add that particular term, so that the equation still stays the same as before. So, given that the equation stays same as before, we have added and subtracted the same term, which is the potential outcome for the group of people who were treated had they not been treated. Now, we move around the terms just a little bit to arrive at this expression. So, we have just moved around a few terms over here, as you can see, and now what we have is expectation y1i given di equal to 1, which is the potential outcome for the group of treated had they been treated, which is y1i, and the minus the potential outcome for the same group which is treated had they not been treated, which is y naught I, and then the remaining terms are added and subtracted. Now, can you guess which part of this equation reflects the treatment, the true treatment effect or the average treatment effect? So, if you have thought about it already, then let me give you the answer. So, the first part of on the right hand side, what you have is actually the true treatment effect on those who were treated. So, this is essentially giving you the effect, the true treatment effect, because what you are doing here again are theoretical concepts, as you see, because we have just manipulated the observed equation on the left hand side, the observed numbers on the left hand side to arrive at this expression. So, what you have here on the right hand side, the first term is the difference in the potential outcome for people who were treated in the state that they were treated, which is y1i, and in the state they were not treated, which is y naught I. So, basically what you are doing is you are looking at the same individuals who were treated had they been treated, which is y1i, had they been not treated, which is y naught I. But then you are also left with this second term in this equation, which is the difference between the individuals who went to the treatment group di equal to 1 and the individuals who went to the control group di equal to 0. And what is this difference? This difference is in outcomes of these two groups before they were actually treated. So, what you have over here is the inherent difference between people who went to the hospital and people who did not go to the hospital before they actually went to the hospital, and this is their inherent differences in health status, because remember Y reflects the health status of individuals. So, what the later part of the equation is giving you, the second part, is the difference in health status of individuals who went to the hospital and individuals who did not go to the hospital even before they actually went to the hospital. So, the baseline difference in health status between these two groups, and if you have to put the same equation in, to understand this better, we would run it on the second example that we just saw in the context of the labor market job training program. So, suppose D reflects your participation in the job training program and suppose Y reflects your earnings. So, you are interested in what is the impact of the job training programs on earnings of individual, and what you observe on the left hand side is the average earnings of people who participated in the job training program and the average earnings of people who did not participate in the job training program. And then when you manipulate the equation, the first term again reflects the average treatment on the treated, which is basically for people who actually participated in the job training program, what is their average earnings had they participated minus their average earnings if they did not participate. So, this is the causal effect that you are interested in, because you are treating the same group of people and not and observing them after the treatment, and then again going back in time, not treating them and observing their outcome had they not been treated, and they taking the difference between the two, which is the causal effect. But then the problem is that when you take the difference in the observed values of yi, then you are also left with this term, which is the selection bias, due to the fact that the individuals who voluntarily participated in the job training program have a very different earning function or an employment probability to begin with, which is reflected in y naught I, when they are compared to individuals who did not participate finally in the job training program, which is reflected by di equal to 0, and this term is called the selection bias. So, this term, the selection bias, is the difference in average y naught I between those who were treated, which is di equal to 1, and those who were not treated, which is di equal to 0. So, ultimately what you have is, when you look at the observed difference between di equal to 1 and di equal to 0, that is people who voluntarily participated in treatment and people who voluntarily did not participate in treatment, and you take the observed differences in outcome between these two groups, you not only have the causal effect, but you also have this additional selection bias in there. So, what you need to do is, you need to come up with a technique that would allow you to take out the selection bias from this term, and then what you are left with is only the causal effect of the treatment. So, this is achieved by randomized assignment or a randomized experiment. How is this done? So, in a randomized experiment by definition means that you are assigning the D, assigning the treatment status. So, for instance, in the hospitalization example, what you would do is, you would have a group of, let us say, 100 people who have some distribution of sickness between them or health status in them, but you would randomly pick every individual and decide whether to put them in the hospital or not. So, for every individual in your sample of, let us say, 100 people, everyone has the same probability of going to the hospital. It does not depend on any of the characteristics that this individual has, and it does not depend on their initial health status. So, in other words, what you are doing over here is, you are assigning di randomly so as to make it independent of y naught I, which is the initial health outcome. In the labor example again, this di is the participation in the job training program, and what you are doing is you are randomly putting an individual in a job training program so that it is independent of their initial earnings capability. So, suppose you can think of the experiment as you have a group of 100 individuals who have spent maybe 5 years in jail for some crime they had committed, and they have been convicted due to the crime. So, they spend 5 years in jail, but now after they come out of the jail you want to give them some kind of job training and want to understand that whether this job training helps them to enter the labor market or improves their earnings outcome and their employment probability. So, what you would do is to take 100 of them, randomly pick 50 of them, let us say, and put them in a job training program, and for the rest of the 50 do not put them in a job training program, and then compare the outcomes between these two groups which were randomly assigned the particular treatment of this job training program. So, this leads you to the following condition, that expectation y naught I given di equal to 1 is the same as expectation y naught I given di equal to 0. So, what this means in words is basically in the hospitalization example, the average health outcome, which is the expected y naught I before hospitalization for the group of people who actually went into treatment, who actually went into hospital, that is di equal to 1. So, their initial health status, the average health status of people who were hospitalized is same as the average health status of people who were not hospitalized. So, what you are doing essentially is you are taking an orange and comparing it to the to another orange, because they both have the same initial outcome. So, if they have the same initial outcome, what it helps you to do is to lead you to assign a value of 0 to the selection bias. So, recall that this is indeed the selection bias, the first term minus the second term. So, what it does is it makes the selection bias 0. So, what you are left with in the comparison of the observed outcome between the treatment and the control group, that is di equal to 1 and di equal to 0, you are left with only the average treatment on the treated group. So, and one more change. So, what this condition allows you to do is to take the observed differences between the people who were treated and who were not treated. So, people who went to the hospital and who did not go to the hospital, and say that this is equal to the average treatment on the treated without the selection bias. And then what this independence, the conditional independence assumption that you saw on the previous slide, what this also helps you to do is it helps you to replace this term over here, which is the expected y naught I for the group of people who were treated, by the expected y naught I for the group of people who were not treated, because remember by the conditional independence assumption in the previous slide, these two terms are identical, and then you can replace the first term by the second term, and what you have over here is the expected outcome for people who were not treated, who were in the hospital, and the expected y naught I for people who were not treated, and this is the average treatment effect. So, what you have with complete randomization is you have the average treatment on the treated, which is the effect expectation y1 I minus y naught I for the group of people who were treated, which is essentially identical in a fully randomized setting to the average treatment effect, the expected y1 I minus the y naught I. So, in general what you would have is the effect of a randomly assigned treatment on the treated is the same as the effect of treatment on a randomly chosen individual. This is what it is saying, that so the first part, the average treatment on the treated, is essentially the effect of a randomly assigned treatment. I randomly assign whether you would go to the hospital or not, for a group of individuals, and then you compare them to the people who were not assigned treatment. So, the effect of a randomly assigned treatment on a group of individuals who would all be in the treatment group, because you are comparing expectation y1 I given di equal to 1 minus expectation y0 I given di equal to 1, which is the entire treatment group, and hence it is called the average treatment on the treated. But then the average treatment effect is what is the average treatment effect for anyone, whether it is the treatment group which is di equal to 1 or whether it is the control group whether di equal to 0, does not matter. So, what you end up with is these two terms for the time being, the average treatment on the treated and the average treatment effect, and in a complete in a fully randomized experiment where your treatment is fully randomized and not conditional on anything, what you have is the average treatment effect is the same as the average treatment on the treated. Thank you very much for attending today's session.